All right, quick lesson here. Vectors in one dimension. All right, so currently we've got 4 measurements that are vector measurements. Vectors communicate what 2 things? Direction and magnitude. Okay, magnitude and direction. So the 4 examples of vectors we have that direction matter: displacement, velocity, acceleration, and force now. Okay, all 4 of those have direction. Okay, one way to communicate or draw a vector pictorially is with an arrow. Okay, so the direction part, that's pretty obvious. That's communicated by which way the arrow is pointing. Okay, but the magnitude part, that is communicated by the length communicates the magnitude. So the longer the arrow, the greater the magnitude, the greater the amount of that vector. Good with that? So that could be, for displacement, it would be how far. For velocity would be how fast would be the magnitude. For acceleration would be how quickly you're speeding up, slowing down. And the direction of, the magnitude of force is how strong the force is. Okay. Tell your neighbor. Tell them why.
There's British. It can't be British. There's a difference.
Correct answer is C. The rabbit is going faster, therefore the arrow is longer, and they're going in opposite directions. Okay. So when you hear find the resultant of vectors, the resultant just means the sum of the vectors. So that should not be intimidating at all. You're just adding vectors. Okay. To add vectors in one dimension, it's pretty nice. So if you have 7 to the right plus 3 to the right, that the resultant of those 2 vectors is 10 to the right. Wow, that's crazy. 7 to the left plus 3 to the right is equal to? Wow, you guys are geniuses. 5 up plus 4 down. 1 up, 9 down. There it is. Finding the resultant. Okay. So once you've learned how to add, then the next thing is learning how to subtract. But that's okay, because we can connect subtraction to addition. What's another way we can write A minus B? A plus a negative B. I think I heard it. Okay. A plus a negative B. Now, what does with vectors, what is a plus and minus, what does a positive and negative communicate? Direction. So if I make a vector negative, what do you think that does to that vector? It goes in the opposite direction. Okay. Okay, it makes vector B go in the opposite direction, and then you just add them. Good with that? Give that one a shot. Thumbs up when you have a guess. Talk to your neighbor.
See how much you have to the line. Because I make all these little short notes, and then they always prove it wrong. Prove it wrong. I think it is because it's basically simpler. Yeah. Because if you're slowing down for acceleration, yeah, and you're like, if you're trying to like, and you're like accelerating and stuff. Why is it negative and negative going here? Like positive. And speeding up and positive. Like this. If you start yourself. Speeding up and positive. Yeah. Slowing down.
What do you say? Correct answer. Okay, so which one are we applying the negative to? A. There's plus and negative, so what do we do to vector A? We flip it 180 degrees. Goes in the opposite direction. So this becomes A to the left. So now it's just an addition problem because we've dealt with the negative. So now we've handled the negative. So now it's just A plus this negative. Sorry, B plus this negative A. So we have 5 to the left plus 12 to the left gives you 17 to the left. B. Does that make sense how we're doing that? And that's how you subtract. And that's the end of that lesson.